In the last video, I showed you a handy macro that uses a sketch as a function in order to set the diameters of scaffold sketches to create a cut glass look. I also promised you a couple more macros to make the rest of the process easier. Let's get to that. Start in the part workbench with the revolution and the function sketch. I've added a compound with the two scaffolds, the attached triangle sketches, and the extrudes from those sketches. I have the scaffold sketches at 25 and 30 millimeters above the origin, the point where I want to start the effect. You'll recall from the cut glass sphere that we began at the equator and manually extended the scaffold up to the pole. I used a deep copy of the compound to at least simplify the process. In this case, we have to start at the bottom and work our way up, since we do not have symmetry across the diameter of the shape. I'm also making the cuts 5 millimeters high rather than 10. That would be an awful lot of scaffolds to build by hand, even with the shortcuts. But there's not a lot of thought involved in the whole process, it's just manipulations. This is the perfect situation to be solved by a macro. So I'll select the compound and go to a macro, recent macros, and select NextRow. I'll show you the macro in a moment, but as you can see, it performs the deep copy, moves the scaffold sketch, and reverses the extrusions to turn the geometry right side out again. Also, as a handy feature, it deselects the compound that was selected and selects the newly created compound for us. The hotkey for running the last macro again is Ctrl-Shift-1. So all I have to do now is press it repeatedly until I get to the point where I want to stop the cut glass effect. That's created a lot of compounds that are going to tend to clutter up the model tree. So select all of the compounds, including the original one, and put them in another compound. Rename it to Cut Glass Compounds. Now to set the diameters. Just like last time, each of the scaffold sketches has the radius of the construction circle constrained and named radius. So like last time, select the function and select the cut glass compounds and go to Macro, Recent Macros, Set Diameters. It really does seem to work like magic. If you'll recall from the cut glass sphere, I then selected all of the extrudes and fused them together. That wasn't too hard when it was just a few extrudes, but we have a lot of them now, and it's going to be tedious to open up each of the compounds and select each of the extrudes. So select the cut glass compounds and go to Macro, Recent Macros, Select Extrudes. That one runs fairly quickly. It clears the existing selections and selects all of the extrudes that it finds inside that compound. Since we already have them all selected, just click Fuse. Job done. If you haven't used a macro in a while, it may not appear in recent macros. Not a problem. Just go to Macro, Macros. Select the one you want out of the list and click Execute. Just like in the glass sphere, create a polar array. Set the radius to 0. Set the count to 8. Now select the fusion and the polar array and populate array with copies. Now select the revolve. Select the populated array and cut. And there it is. 3 simple macros turned an all-afternoon job into just a couple of minutes. Like the last one, I have uploaded these 2 macros to my Mixed Macros repo on GitHub. The link is in the description. Starting with NextRow, the first line is the now familiar code to get a list of selected items. In this case, we just need the first selected item. This will be a compound containing 2 scaffold sketches and 2 extrudes and their attached sketches. On line 22, we make a deep copy of the compound. This is a function of app.activeDocument. App is another module from FreeCAD that's automatically imported into all macros. The first parameter is the object to be copied, and the second parameter is a boolean to control if we make a deep copy or a shallow copy. We need the deep copy because that's what copies everything inside the compound and maintains the attachments. If we made a shallow copy, we would simply get another compound that contained the same objects as the first. The result of the deep copy is stored in the variable O for object. Next, assign the two scaffold sketches in the copy of the compound to S1 and S2. Then compute the difference in height between the two scaffold sketches. The print statement is left over from debugging. If the difference is less than 0, that means that S2 is higher than S1. So we need to raise S1 by twice the difference. Otherwise, raise S2 by twice the difference. It's interesting to think that this means the compound is also acting as a persistent global storage for the variables between invocations of the macro. Finally, the direction of the extrusions needs to be reversed. The extrusions will be in the compound's out list index position 2 and 3. Just set their reverse parameter to the opposite of whatever it may be currently. Finally, clear the selection list in the document and add in the newly copied compound. The add selection function wants the name of the compound, not an object pointing to it. Fortunately, name is one of the fields available within the object. The final macro is SelectExtrusions. There's not a lot to it. The first line is a little different. We get the name of the active document. We'll use this later for setting selections. Next is the familiar line getting the complete selection from FreeCAD GUI. Following that, on line 21, clear the current selection. Next, define the function addExt. Its parameter is a list of objects to examine. It acts as a filter, so I've made it a generator function. First, iterate O over that input list. If the type ID of the object is part : extrusion, yield it. Else, if the type ID is part : compound, recurse into addExt with the out list of the compound and yield up each of the results. It's not explicitly coded, but any other object type is simply ignored. Now for the driver of the macro. Iterate over the output of addExt, giving it an input parameter of a list comprehension of the objects from each of the items in the selection list obtained in line 20. Each of the objects yielded by addExt is added to the GUI selection by name. Use the dname variable from the beginning of the macro as the document name. That's really all there is to it. A lot of power and a very small amount of Python code. Let me know in the comments if you'd like to see more macros in my videos. Also, let me know if you'd like me to continue explaining them line by line, or if you just want me to post them to GitHub and let you figure them out from there. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.